Hey guys, these notes are for graphing slope-intercept form. So recently we just learned how to write slope-intercept form equations, and now we need to learn how to graph them. So our essential question is the same: why are multiple representations important? Again, it's just for ease. Sometimes point slope is more beneficial, sometimes slope-intercept is more beneficial. Okay, so let's review slope-intercept form. That is y equals mx plus b. And our m here stands for slope, and our b stands for our y-intercept. So in order to have a linear equation, which is what all Unit 3 is about, we need an x and a y, which is why our x and y are always in an equation. We need an independent and a dependent variable in order to graph things. So we can't get rid of our x and y, they need to be there. Alright, so in order to graph from y-intercept form, I don't know why I said y-intercept form, I just realized that. It should be slope-intercept form. Okay. In order to graph from slope-intercept form, you want to start by plotting the y-intercept. Okay, so since you're given that point, you want to start at that point. And then just like with point slope form, we start with our point and then we use with our slope. So now we're going to start with our y-intercept and then use our slope. So use the slope that they give you. Just as a reminder, you should be taking notes. You're not going to remember any of this, and you're not going to have any examples to look back on if you don't actually take notes. Alright, so before we get into graphing, let's review identifying our slope and y-intercept. So in number 1, what's my slope? My slope here is positive 4. Remember, y equals mx plus b. And our y-intercept here is negative 2. Okay? Over here, slope and y-intercept. Okay, so this gets a lot of people because they're like, well, there's only like an x over there. Well, what is our slope always attached to? Our slope's always attached to our x variable. Well, what number is attached to our x variable here? It's technically a 1. We don't typically write it, so our slope here is a 1. And here we don't have any y-intercept. It's actually plus 0 over here. So our y-intercept here is going to be 0. So it's going to start at the origin. And we just recently also learned direct variation. So number 2 would be a good case and good example for direct variation, a relationship that represents direct variation, but number 1 doesn't because number 1's y-intercept is not 0. Okay, moving on, we have y equals 5 minus x. What's our slope here? Okay, now you might want to say 5 because it comes first, but it's always a number that is attached to your x, which is a negative 1 in this case. Okay, and our y-intercept here is 5. Alright, and number 4, what's our slope and what's our y-intercept? Now you're wrong if you say the slope is 3, and you're wrong if you say the y-intercept is 12. Here's the reason why. Is this in slope-intercept form? Is this in y equals mx plus b form? And you're like, well, yeah. Well, in slope-intercept form, my y is by itself. Right here, my y is not by itself. So in order to get it to slope-intercept form, I need to divide everything by 4. Okay? So I have y equals 3x divided by 4 plus positive 3. And then I'm going to go ahead and write my slope to the side because I don't want it in the numerator. I want to clearly see what my slope is. So in this case, my slope is a positive 3 over 4, and my y-intercept is a positive 3. Now that's a lot different from what we had when we began with, and that's because it wasn't in slope-intercept before. Alright, last one. Here, again, it's not in slope-intercept form. We don't know how to find the slope or y-intercept from this form. So we need to start moving things. Now the two most common responses I get are, okay, we need to divide by 2, or we need to subtract 3x. Okay? So let me ask you, if I had 3 plus 2y equals 6, what would you do first? And you're like, oh, okay, subtract 3. Well, over here we're going to do the same thing. You want to subtract the 3x before you divide by 2. Remember, it's PEMDAS backwards when we're solving, so you want to see if you can add or subtract anything before you multiply or divide. And here I can subtract 3x before I can divide by 2. So I have 2y equals 6 minus 3x. Remember, 6 and 3x are not like terms, so they just stay separate. And then here, just like I did in number 4, I'm going to divide everything individually by each term. So I'm going to divide this one by 2, this term by 2, and this term by 2. Okay? we have y equals positive 3 minus 3 over 2x. So our slope here would be a positive, actually no, it's a negative 3 over 2. And our y-intercept is a positive 3. Okay, so if it's not in slope-intercept form, you will need to move it into slope-intercept form to find that slope and intercept if they ask you for it. Alright, here's the fun part. We actually get to graph now. Okay, let's first identify what is my slope. Well, it's going to be positive 2, but when I'm graphing slope on a line, I like to do rise over run. So how can I write 2 as a fraction? Well, that's going to be 2 over 1. Okay? And when we were graphing point slope form, I wrote down 2 different slopes that we could use, and I'm going to do the same thing here. Because sometimes when we use our slope, we don't actually have room enough to keep graphing, so we want to have a different option in case we have to draw the slope the other way. So positive 2 over 1 is the same thing as negative 2 over negative 1, right? These things both give me a positive 2, but I just have 2 different options for my slope here. You don't have to use both unless you have to. And then our y-intercept here is negative 3. Again, with our steps with graphing slope-intercept, we want to start at our point, which is our y-intercept. Our y-intercept is going to be on our y-axis at negative 3. Okay, and I'm going to use my first slope of 2 over 1. I'm going to go up 2 over 1. So I have a point here, up 2 over 1. Okay, I typically am looking for 3 points, so as long as you have 3 points, I'm good with that. And you always want to check to see if your line matches your slope, right? My slope in my equation was up 2 and it was positive, so I should have a positive line, and that's what I have over there. A positive line increases from left to right. So going from left to right, it needs to be going up, and it is. Okay, moving on. If you want to try this one on your own, you can. If you want to pause the video. Alright, so our slope here is going to be negative 1 over positive 2, or 1 over negative 2. Regardless, when I put that in the calculator, I'm still going to get negative 0.5. So I want to just write both slopes just in case I need it. And then our y-intercept here is a positive 2. So you want to graph a positive 2 and then use your slope. It's rise over run. So I'm going to go down 1 and then I'm going to go to the right 2 because it's a positive 2. Okay, down 1 to the right 2. I can actually keep going 1 more. I'll just go ahead and plot 4 points there. Oh, that's an ugly point. Come on. Okay. That is my line. Now my line here is negative, and then you look at your slope, my slope's negative. Okay, so that matches. At least I graphed in the right direction. If your slope is negative and your graph is in the positive direction, you graphed it incorrectly. Okay. Next one. What is my slope? My slope is negative 1 over 4, or 1 over negative 4. Again, I'm still going to get negative 0.25. And then our y-intercept here is technically 0. We don't have one here, so our y-intercept is 0. They didn't have a number there for us, so we have a y-intercept at the origin. And then I'm going to use my slope of negative 1, and I'm going to go to the right 4. And then I'm going to go, now I don't have any room to keep going, so I'm going to use my other slope. So in that first one, in this first one, I went down 1 over 4, using my first slope, and now I'm going to use my other slope, which is the same thing but the other direction. And you want to start at the point that you started at. You're going to go up 1 to the left 4 because it's negative, and then plot a point there. Okay? And again, your line should be negative. That is a horrible line. Your line should be negative because your slope was negative. Alright, number 4. It's not in slope-intercept form, so you need to put it in slope-intercept form in order before we can do anything. Just like with the first example, what are we going to do, or with that number 5 in that first section of reviewing, what did we do first? Well, I need it in slope-intercept form, so I need it in by my y by itself. Well, if I had 3 plus 2y equals 8, the first thing I would do would be to subtract 3. So over here, you're going to subtract 3x, okay? Don't treat it any differently just because there's an x there. 2y equals 8 minus 3x. Okay? My y is still not by itself, so I'm going to divide everything by 2. And you want to divide each individual term by 2 because that will make your life way easier. We have y equals 4 minus 3 over 2x. Okay? Again, I'm writing my x on the side so that I can clearly see my slope here. my slope is going to be negative 3 over positive 2, or 3 over negative 2. Again, I'm still going to get negative 1.5, whichever way I type it in the calculator, and then my y-intercept is a positive 4. Okay, sorry about that. Okay, and then we are going to plot our y-intercept at positive 4 on the y-axis. Remember, y-intercept, y-axis. And then we're going to use our slope. So I'm going to go down 3 and then to the right 2 because it's a positive 2. And then I can't go the other way, so I'm just going to keep going in the same direction I've been going. So I'm going to go down 3 over 2 again. So I use this slope twice. I never even used the second one, but I still want the option, so that's why I write both. Ew. I cannot draw a line today for some reason. I know you can hold it down and then draw your line, but I'm too lazy for that, so I'm not going to do that. Okay. Number 5. This one's very similar to number 4, so if you would like to give that one a try on your own, you can go ahead and pause the video. Alright, so we have x plus 5y equals 10. We want to get y by itself, so the first thing I would do would be to subtract x on both sides, and I have 5y equals 10 minus x. Then we'll divide everything by 5. Y equals positive 2 minus, now I have an x divided by 5 here, but what's technically in front of my x? A 1. Technically a negative 1. So I have negative 1 over 5 x. Okay? So my slope here will be negative 1 over 5, or 1 over negative 5, and my y-intercept is a positive 2. Alright. So my y-intercept is at a positive 2, and then I'm going to use my first slope over here in pink. Negative 1 over 5, so down 1 to the right 5. And then I'm going to use my other slope, because I can't keep going in that other direction. I'm going to go up 1 and to the left 5. Okay? Boop. There you go, you got a line. Again, you always want to check. Your slope was negative, so your line's negative, and that's good. So y-intercept's at 2, we're good. You always want to look at the most recent equation that you created. So don't look back at what we started with, because we rearranged some things. It's the same equation, we're just rearranging stuff. Okay? Next, in number 6, this is a little different. You're like, this one doesn't have an x. What is it? What's going on? So normally we have y equals mx plus b. Do I have an x here? No, my x is technically gone. What's the only number that multiplies by something and makes it 0? 0. So our slope here is actually 0, and then our y-intercept is 3, that's why we got y equals 3. So our slope is 0, and our y-intercept is 3. Okay, so let's go find the point 3. Now it's y equals 3. So am I going to look at my y-axis or my x-axis? You're going to want to look at your y-axis. You're going to go up to positive 3, and you know this is a slope of 0, so you know it's going to be a horizontal line. Okay, and if you can't remember that, just think about how your tick marks on your y-axis go side to side. You're going to draw a line side to side like that. And if you want to make a note to yourself, if I have y equals a number, that means I'm going to have a horizontal line. That does not look like the word line. Let me erase that. Line. Okay, and then on number 7, we have something that's kind of the opposite. We don't have a y here, but we have an x. So if the other one was a slope of 0, what's the opposite of that? Or better yet, the other one was y equals a number gives me a horizontal line. So x equals a number is going to give me a vertical line. What kind of slope does a vertical line have? Do we know? That's going to be undefined. Remember, there's 4 types of slope: a positive, negative, 0, and undefined. Now, this is x equals a number, so we're going to look at our x-axis, and you want to find negative 2 on it, which is over here. And then again, it's a vertical line, so it's going to go straight up and down. And if the only way for you to remember that is just to remember that your tick marks on your x-axis go up and down, so draw a line up and down. Alright, number 8 is where we get into more different things. The different thing about this one is that it's not an equation, it's an inequality. Now, it's already in slope-intercept form, right? If I pretended this was an equal sign, it's already in y equals mx plus b form. So what is our slope here? It is going to be positive 5 over 3, or negative 5 over negative 3. And our y-intercept is going to be -3 here. So you want to go to our y-intercept and plotting -3, and then we're going to go up 5, 1, 2, 3, 4, 5, and then over 3. And then I'm going to try to keep going up one more, even though I know I don't have room. 1, 2, 3, 4, 5, 1, 2, 3. So it's going to be right there. Okay? And I want you to always try your best to plot 3 points if it's possible. Alright, and then what did I do wrong here? Well, this is an inequality, right? So let's look at our signs. And from point slope form, maybe we remember, maybe we don't. So let me zoom in a little bit. If we have a less than or a greater than sign, my line is going to be dotted. Okay? If I have a less than or equal to or greater than or equal to, my line is going to be solid. And the best way to remember is this: I have a solid line here, so I'm going to have a solid line here. Okay? So in this case, would I have a dotted or a solid line? I would have a dotted line. So I'm going to have to draw a bunch of dashed or solid lines, dashed or dotted, whatever you want to do, whatever you want to call it. Whoops. And then when we are graphing inequalities, we also have to shade, right? Like when we have numbers and inequalities, we shade either left or right. Well, this one's going to be either above or below. So our inequality sign here is a greater than symbol. So when you're thinking of greater than, you think of above. And so the above part of my graph would be over here. Okay? And you're like, wait, I'm confused. Okay. Above or below, right? Let's pretend that dotted line as a pencil. Let's pretend this is a pencil. So hold a pencil up at that angle. If you were to drop the pencil down at that angle, it would fall down to the right. So this section over here would end up being your bottom part of the pencil, below your pencil. So you don't want to shade over there because this is greater than. And I know it's hard to like visualize that, so if you have a question about that, please come in and ask. It will make more sense in person. But the above part of your graph will be to the left in this one. Now a solution is anything located in the part that you just shaded. So this would be our shaded stuff. Okay? So it's any point. So it could be the point 0, 0. It could be the point -5, 5. It could be the point -10, 10. As long as it's in the shaded spot, it's a solution. Now anything that is a non-solution is in the unshaded part. So for example, 6, 0 is not a solution. It's not in the shaded part. Or what about 5, -2, 4, -2? That's also not a solution. Now let me ask you this one. Question. Is 0, -3 a solution? Now, if you haven't figured out where 0, -3 is, that is actually on your line here. But do you think it would be a solution because it's on the line? The answer to this one is going to be no, because my line is dashed. Well, what does a dashed line mean? It means I just have a greater than or a less than. It's not equal to. So if I have a point on there, it can't equal that point. So anything that's on that line for this problem would not be a solution. So 0, -3 would be part of the, 0, -3 would be part of the non-solutions. Okay? Now if this was a solid line, then 0, -3 would be a solution because it is equal to, so it can include that. Alright. Number 9. If you want to try this one on your own, you can, but just remember it does have to be in slope-intercept form, and it is not in this case. Alright. So we want y by itself, so I'm going to go ahead and subtract 3x from both sides. I have y is less than or equal to 2 minus 3x. And now it's in slope-intercept form. I mean, it's in slope form, but you know, you get the gist. Alright, our slope here is -3 over 1, or 3 over -1. And our y-intercept here is a +2, okay? So I'm going to go up to +2, plot a point, and then I have to go down 3 over 1, and I can keep going down 3 over 1, so I don't even have to use the other slope, but I can if I want to. Okay? Oops, I accidentally drew a line again. Let's check. My inequality here, you always want to look at the most recent thing that you created. So that's our most recent equation, or inequality, my bad. And we have a less than or equal to. So since I have an equal to, I do have a solid line. Now we have to shade. Now it's less than. So you want to shade below the line. And below the line would be located over here. Okay? Again, if you hold a pencil up in the air at that angle and you were to drop it with normal gravity and everything, your pencil would fall to the left. So your left side would end up being below. Okay, let's pick something that's a solution. something that's located in our solution area, our shaded area, would be 0, 0. Okay? And a non-solution would be the point maybe 4, 0. Okay? It could be any point. You don't have to list more than one, but you can. But you can literally pick any point for your solution as long as it's shaded, and the non-solution if it's unshaded. And then in this case, let's look at a point on the line. Let's look at this point, 0, 2. Where would 0, 2 lie? Would that be a solution or a non-solution? Okay, now that's on the line this time, but our line is equal to. So that would mean that it is part of our solution. So 0, 2 would be a part of the solutions. Okay? Alright, we got 3 examples left, so we're almost done. And the last 2 are pretty easy. Alright. Go ahead and try this one on your own if you haven't done so already. It's very similar to just doing the other equations one. You just got to move stuff around. But you must be very careful on this one. There's a little trick to this one. Alright. So, first thing I'm going to do is subtract 3x from both sides. So we have negative 4y is less than 8 minus 3x. And then I'm going to divide by negative 4. Now this gets a lot of people in class because they're like, what did I do wrong here? I don't know what I did. Okay, and just wanna say something. Negative 3 divided by negative 4. So a negative divided by a negative is going to be a positive. So I'm going to put a plus 3 over 4x. Now what did I do wrong here? Have you caught it? And you might not have because you might have forgotten. When I divide by a negative, what happens? My sign flips. My inequality sign is going to flip the other way. Sign flips when dividing by a negative. And this is something you learn in middle school, but it's something that we kind of forget sometimes. So since we divided by negative 4, our less than sign is now a greater than sign. So I want to go ahead and box that so I don't look at any of the other stuff. I want to look at just my new inequality. My slope here is positive 3 over 4, or negative 3 over negative 4. And my y-intercept is a negative 2. So I'm going to plot that at negative 2, up 3 over 4. And I'm actually going to have to use the other slope in this one. I'm going to go down 3 to the left 4. Okay? Positive slope, positive line. We are good to go there. And I accidentally messed up again with my line. This is a greater than sign. There's no equal to, so it is going to be a dashed line. Okay? And now I need to shade. Well, this says greater than. It's a greater than symbol. So I'm going to shade above the line, which is over here. Now remember, if it's greater than, you shade above. If it's less than, you shade below, right? When you think of someone less than you, they're like below you, so you shade below. Okay? Sorry, I keep saying K. I don't know why I keep doing that. Okay, and then our solution would be anything in the shaded, which happens to be 0, 0 again. The point 0, 4 is also a solution because it's on the y-axis up there. A non-solution would be like 5, negative 5, or 10, negative 10. Okay, something in the non-shaded. And then anything on the line here would also be non-solution. So our y-intercept of 0, negative 2 is also a non-solution because it's not an equal to line. All right, moving on. We have y is less than or equal to 3. Now, there's nothing else but y and a number. So you want to treat it like the y equals a number. So you just want to look at your y. Now I'm talking about the y, so I'm talking about the y-axis. And then you're going to find positive 3 on the y-axis. Okay? And then you know that y equals a number is always going to be a horizontal line. And then this line is actually going to be solid because it is equal to. And then you need to shade. So this says y is less than or equal to. So you want to think of less than, so that's below. Now hopefully you can find below on this one because this one's flat out very simple to find. Your below is going to be right here, below the line. So a solution would be, again, 0, 0. That's like probably the easiest point. I always like to use that point because it's, again, the easiest point to write. A non-solution would be 0, 4, or 5, 5, or 1,000, 1,000, right? Anything in the non-shaded up there is not a solution. A solution here would be anything on the line as well because it is equal to, so 0, 3 would be a solution. Okay. Lastly, we have x is greater than 2, and here we only have just an x and just a number. So since it's just an x, we're going to look at our x-axis, and then you would find positive 2 on it. So if you had like x and a negative 5, then you would plot negative 5 on your line. And then since this is x and a number, it's going to be a vertical line, but it's only greater than. So your line should be dashed. Okay? And then you're like, whoa, there's no above or below here. Okay, well, if I asked you to graph this on a regular number line, right? X is greater than 2. So where are all the numbers greater than 2? To the right. So you would shade everything over here to the right. So a solution would be, let's see, 6, 0, right? Something over here. And then a non-solution would be 0, 0. Okay, something in the non-shaded area. And again, this is a dotted line, so anything on that line is not a solution. So the 2, 0 is not a solution in this case. But that is it for graphing slope-intercept form. I love graphing because all you need to do is just plot the point and then use your slope. As long as you use the slope correctly, then everything should be fine. If you have any questions, feel free